Hi, everyone, and welcome to July's virtual lecture. I'm Carla Gonzalez, and I'd like to introduce you to our speaker today, Dominique Fournier, who will be giving us a sneak peek of our latest customizable Python user interface in Geoscience Analyst Pro. And he's also going to give us some tips and tricks on how to get started with geoapps. If you have any questions during the presentation, feel free to type them into the Q&A or raise your hand, though Dom may wait till the end to answer the question. And just a reminder that this lecture is being recorded and it is going to be available on our YouTube channel in the coming days. And without further ado, go for it, Dom.
Thanks, Carla. So you see the slides, we're good to go?
Yep, all good.
Perfect. So yeah, it's my pleasure to be able to demo a new feature that's coming up in Geoscience Analyst. It will be released officially in Q4, but we're going to have like an alpha preview version in 3.31. And basically, like in short, what it is that this feature will let you be able to trigger Python applications directly from Geoscience Analyst, including and be able to create a small user interface. You know, select object, put values in, click, start an application, and then get the result being sent back to your project. And so I guess before I dive into it, oh yeah, I should have shown this slides. So be able to create a small UI, trigger an application, and then get the result back up. All right, we'll see this in more details. Just a little background. Since probably a year and a half ago, we started putting together some small Python applications, geoapps. And this is kind of a continuation of this. You might have seen videos before, but basically that gave the first intro to Python users to be able to interact with the GeoH file format, change values, change their data, modify the objects, write it back to the database so that analysts could display it. So it's sort of a one-way communication. And then today we're going to be introducing the other way, where now analyst is the driver. Analyst triggers the Python application, and then the results can be sent back using the monitoring folder. I will demo all this. Maybe it sounds a little bit complicated, just like that. So let's just get to it. I will start a session of Geoscience Analyst, and then on my desktop here, you see that I have a few things. So I'm going to show you two very simple UIs, right, that I created just for this video. I'll put them in a link on YouTube so you guys can try it at home. So I have two ui.jsons, and this defines how things are going to look like. And then I have some Python scripts in this folder here. Okay, don't have to worry too much about this for now. So the ui.jsons get triggered by sliding into the main viewport. And if I do this, then it shows what's written inside. You know, all the parameters that are written in the ui.json are being displayed in camera. And then that would let you select objects. So right now I have nothing in my project. That's fine. It's just a little hello world application. Select an object, click, run the function. And if I click OK, then it's going to save, ask me to save my parameters. I'm just going to overwrite my hello world. Okay, and then execute a Python command. All right, it's nothing complicated here. I didn't select any object. It's just hello world. I'm reading it. I'm doing something. All right, just a bite size, just a building block here. Notice that when I click OK, it also created a temporary, small geoh file. So you have the option, if you didn't want to send the results directly into your main project, you could always just work in this temporary file that has all the objects that were selected. Let's do something a little bit fancier, a little bit more interesting. So I will open the demo Flin-Flon project, which has a lot more things in it. If you're not a Geoscience Analyst user, otherwise you would know that Analyst is a strong, powerful 3D viewer that can store many types of geoscientific data. For instance, here, let me just only show, I have a geochem data, let's say, and I have a 3D mesh. And then I would like to transfer data directly from my geochem to my 3D mesh, right? So this is an operation currently that Analyst doesn't have the utility directly in. Maybe you're like me, you're impatient and you would like to be able to do this operation right away. So this new ui.json Python application will let you basically write your own and execute it directly there. So that's what I did here. I created a small data transfer. Okay, so I'm just gonna drag and drop. And it's a very simple one. You know, it's not as complicated as the geoapps that you might be familiar with, but it's basically letting you select a source object. You can either use a drop down or select using the click button. I'm gonna grab something, okay, some data on the geochem, and then say, send it to my mesh. So if I just do this operation, it would basically run it and write it to the temporary GeoH5. Here I'm going to do something even slightly more interesting. I would like to be able to see the result directly coming straight in my active session, right? So I'm going to make use of the monitoring folder. So I'm going to turn the monitoring folder active like this. Let's do it again. So I'm going to drag and drop, transfer it to my mesh. And now I'm going to execute the command. Okay, as before, just ask me to save. I'm just going to overwrite. Okay. And as soon as I do this, it runs the application. And then now I have a property directly populated onto my mesh. All right, so maybe it went a little bit quickly. Let's do it again. I'm going to do data transfer, and let's pick something else. Like, let's say we're going to send geochem data and then run the application. Click OK, override. And it's done. And now I have a new property on my mesh called geochem. It's just a nearest neighbor. The operation is not very interesting. I mean, it could be much more complicated. But I think it shows well the power of this new feature where you can either you create or you contact us. You email Carla for, you know, you have an idea, we have a special feature, and then we can quickly prototype small utilities for you. So let's just dive down just one level just to quickly show you how things are working. So when I triggered this, you see that there's it asks to run a function, and it basically is in the definition of the ui.json. I can tell it to run any command that I would like. It's going to be expecting a Python command, and here it's the function interpolate that lives in just my scripts here. We need to, in the 3.3.1, you'll have to set in your preferences to tell where to look for your scripts, right? So here, in my preferences, I just say, look, Windows, go add this my scripts into your environment. So if I call interpolate, it knows where to get it. And you also need to tell Geoscience Analyst, where to get the Python exe. Here it's in my, it's pulling from Anaconda. You don't need Anaconda, but my Python installation was done with Anaconda, so it's taking it from there. All right. And so when I click OK, then Geoscience Analyst called Python. Python calls this command here with the ui.json as argument. And now let me just give you a quick look what the function looks like. Again, I'll give you this script after with the video as a link. But basically it might look a little bit scary if you're not a Python user, but it's always going to be the same syntax. You first need this entry point here, which takes the ui.json as an argument, parse it out as a dictionary, and then pass it to my interpolation function. And this is where the magic happens. You as a user or us to help you can write anything that we'd like. So we're pulling objects from Geoscience Analyst using geoh5py, the data, get some geometry, use scipy ckd3 for the nearest neighbors, and then writing the result back out. And if the live link is on, then I'm just doing an extra step here of copying this to the monitoring directory. You don't have to go down the details here. It's beyond the scope, but and we'll write documentation to help you out. But hopefully, this shows you that it's not too complicated to get started. The first thing you'll need is, of course, being on 3.31. Here I'm on the alpha version once it's released, and have Python installed on your machine, and then you would be ready to go, ready to script, ready to write your own ui.json. That's about it. To get started, you can, if you want to use the default installation that we recommend to our users, you can always go to the geoapps. Just Google geoapps on getting started, and then it will take you through the installation steps one at a time. Having Anaconda will obviously give you Python directly, and you could technically just stop here if you didn't want to have the geoapps.
Right. So Don, speaking about installing the geoapps, would you just be able to refresh our memories on how to install that? I think you just might have, but is that it? You just go in there and download Anaconda, install Anaconda?
Well, hopefully, yeah, hopefully you can just follow the getting started, right? So download Anaconda. This is about, I think it's about 500 megs. So it's a pretty big installer, but they'll give you all, many packages that you need to be able to do geoscience. And then kind of separate to this are the geoapps. So basically everything all the applications that we put together here, you'll be able to get access to those Jupyter notebooks. It's different. It's a different topic than the ui.json, right? We're in a more like a pure Python here, but this is how you get started. Yeah. And then from this folder, let me go to it. You'll have a install or update.bat where you just fire it up, and then this will download all the requirements, all the Python requirements. And once that's done, you can just start the application using the start application.bat.
Right. So in case we want to install those geoapps in another directory that's not the default directory, are there any steps to take to make sure it all works properly?
Yes, yeah, that's right. So this install.bat here, if I look at it, it expects that Anaconda is installed in a C user profile, and some people install Anaconda somewhere else. So if you have installed Anaconda outside that C user, you'll need to edit those paths here and the start application.bat. We put the you'll need to edit those paths. So yeah, we put the docs here, but some people just browse through it and don't see it. It's basically in red. If it doesn't work, maybe it's just because of this kind of like the most common frequently asked question. Yeah.
Right. So then afterwards, when you run the application, do you ever get an error along the lines of like geoapps libraries cannot be found? And if so, then what can we do to fix that?
Yeah, that's right. Well, if the paths weren't changed properly or something happened during installation, then it's not going to work, right? Let me just, since we're recording it, if you open an Anaconda prompt, right, you can just use the Windows search button and start typing Anaconda prompt. Here you can just do conda and then list. And if you don't see the geoapps in the list of environments, that means the installation didn't work, right? So you can probably just from here, just navigate to the geoapps folder and then launch the installation directly manually. And then we'll be able to help you better by looking at the log that way. Yeah. And we kind of digress from the ui.json here, but it's useful. It's all useful information.
And after I do all of that and I'm still getting my error of the libraries cannot be found, what do you think might be going on there?
Yeah, well, okay, so usually it's just because when you reopen the notebook, the last time it was run, you'll see you'll see the log from the last time it ran, and so sometimes you just need to rerun the application. I don't know if yeah, it doesn't really show it here, but if you still see a message after you reopen, just rerun the cell to make sure that you're refreshing basically. Yeah. Okay. Shift enter or run. Yeah.
Makes sense. And just looking at your list of geoapps, I think you have more than I do. It might be that I missed an update. How do you make sure you always have the latest version of geoapps installed?
Yeah, it's a bit my fault for not communicating better, but basically download often. If you go to the site and then just re-download the folder, you don't need to rerun the install most of the time. You just want to download the latest folder, okay. And then you don't have to do anything. Just start again the applications from the start.bat. You'll be ready to go. Yeah.
Okay.
And
great.
then about this, I think that was it for me. Yeah. I had one more slide just to recap a little bit, just not the geoapps, but strictly the ui.json, right? What we managed to accomplish basically now is to have a two-way communication between Python and Analyst without the Jupyter notebooks. That's it. If you guys have any questions, feel free.
Yeah, I think I've been monopolizing all of the question time there, Tom.
That's good.
But yeah, any of those are in the lecture. Please feel free to type any questions you may have or raise your hand. And we actually do have one question here. Is there any difference between this Python geoscience demonstrated using geoapps and the Python integrated into Schlumberger tech log?
No, yeah, I'm not familiar, Eugene, with Schlumberger tech log. I would just say that probably not. I mean, there's a lot of software that uses Python as a computational engine just because it exists. You know, there's so many good functions that already exist, and all we're doing here is giving you the possibility to access it, right? So use the powerful 3D viewer of GA. This is its own, shiny product that does great things for slicing and viewing the data, and then just be able to access the computational engine of Python. Yeah. And then Lucas, the video will be shared on YouTube.
Yeah, after. So that was my next point, that we're going to be uploading this video to YouTube in the next coming days. So you'll be able to access this presentation here if you missed anything, you want to rewatch it again. And if you do have any more questions at any point, any ideas, suggestions, anything like that, please don't hesitate to email us at support@geoscience.com. And we'll be getting back to you as soon as possible.
Wonderful.
Great. Well, thank you so much, Dom. And thank you everyone else for coming.